So I have here a 3D printed Munger sponge, which is designed so that it can be taken apart, revealing what is by now a reasonably famous 2D cross-section. And when you look at the structure of this 2D cross-section with its 2D star holes, it begs the question, if you were to somehow take an analogous 3D cross-section of a 4D Munger sponge, would you end up with some kind of 3D solid with 3D star interior cavities? The answer is a bit nuanced because there is more than one way of generalizing the Munger sponge to 4D. However, I claim one such generalization does yield this structure, and moreover, this is it right here. So I'm just going to turn this so that you can get a look at the structure. The outer shell turns out to be an octahedron, but I've just rendered it as a wireframe so that you can see clearly the interior stars, which turn out to be stellated octahedrons. So what's going on here? Why are we getting this result? Let's try and understand it. Here I have a 3D Munger sponge with recursion depth 1 in X-ray mode. And what I want to draw your attention to is the structure of the interior hole. You can see that it consists of 3 mutually orthogonal tubes intersecting in a kind of 3D plus sign. And I've drawn a white dot at the center of intersection. And what I want you to notice is that if I now add in the plane of intersection, that white dot lands precisely on that plane. Moreover, if we now go to recursion depth 2, you will see that in every single case, that white dot, the center of intersection, is landing exactly on the plane. This suggests that we should study what happens when a 3D plus sign is intersected with a diagonal plane that is moving towards the center of the plus sign. As you can see, when we reach the center, we get precisely a Star of David. This explains the Star of Davids that we observed in the 2D cross section at the beginning of the video. But what if we had a 4D plus sign and we intersected it with an analogous 3D hyperplane? Well, if the hyperplane misses the center of the 4D plus sign, then we get something like this. However, if I now start to move the hyperplane, which of course you can't see, towards the center of the 4D plus sign, you can see that those 4 diamonds converge together and they ultimately form a 3D star, which happens to be a stellated octahedron. So I've got here a 4D Munger sponge, and what the previous result tells us is that if the structure of the holes contains a lot of 4D plus signs, then we can expect to see these 3D stars when we cut it open. However, I claim that this 4D Munger sponge isn't going to work. The key to making it work is this alternate 3D Munger sponge that you can see here. The holes in this alternate Munger sponge are actually all interior cavities invisible from the outside. So we're viewing it in X-ray mode. I claim that a 4D Munger sponge constructed such that each face is this alternate 3D Munger sponge gives us the structure of holes that we are looking for, giving rise to these stars. To see that this is true, let's chop this 4D Munger sponge with a diagonal hyperplane that moves gradually towards the central cross-section that we saw at the beginning of this video. Thanks for watching.